So let's take a look at this radical review. It's broken down into the three sections that we've done. We did the simplifying radicals, which then led us into the small change of adding and subtracting radicals, and then the small change of rationalizing the denominators. Simplify each of the following. So we're looking at these, and we're looking at trying to break down the radicals so that they're in simplest terms. Number one, the square root of 45. There's two ways to do these. So the first way is that I want to look for a perfect square in there. And I know that 45 is 5 times 9. And so if I break it down into those two roots, then I can simplify. The 9 I put second just to show you that it doesn't always have to go first. 5 times 9 and 9 times 5, either one would happen, would get us to the same place. So the square root of 5 is not a nice answer. And the square root of 9 is 3, and usually we would put the whole number in front. In fact, if you put it behind, I will actually mark it wrong, so please make sure you put it in front. Number 2, I've got a 32. Now, if I didn't know what a perfect square was in 32, I can take 32 off to the side, and I can break it down. I know that 32 can be divided by 2. That's 16, and I know that 16 is 4 times 4, and I know that 4 is 2 times 2, and 4 is 2 times 2. Well, I'm looking for pairs, but I have a bunch of 2's here. I've got 5 2's. That give me 32. 2 times 2 times 2 times 2 times 2 gives me 32. So I'm looking for pairs here. I've got a pair of 2's. That pair of 2's can come out of the radical. A pair of 2's, that pair of 2's can come out of the radical. But I've got this lonely 2 up here that doesn't get to come out. So 2 times 2 is 4. And the square root of 2 is the radical part of this answer. I can do the same thing with 16, but look what happens with 16 when I do that. This is 4 times 4. I have a pair of 4s, so I can actually stop there. Once I have pairs, then I could stop. Okay, and so keep in mind what we're looking for. The definition of a radical, or one definition of a radical, is the common pairs of factors. So I'm looking for a pair of factors. There's a pair of factors, 4 times 4. So those 4's get to come out, and if you hopefully know that the square root of 16 actually is 4, so that gives us the answer of 4. This is where it's fairly nice for us to use the method of breaking them down for number 4, so 147. Well, I don't know any perfect squares that go into 147. So I'm going to say, well, I do know that 7 goes into 14 and 7, so 7 times 21 would give me 147. And then 121 is 7 times 3. Now I have a pair of 7's, and the pair of 7's get to come out of the radical, but that 3 that was left over does not. So I get 7 times the square root of 3. Well, when I have a number in front, let's jump to, let's say, number 7 here. When I have a number in front, that number needs to continue with my radicals. So I've got 3, and then I'm breaking down the 20 into 4 times 5. So I still have that 3. The square root of 4 is 2, and the square root of 5 is the part that makes this an irrational number. 3 times 2 is 6 with the square root of 5. Number 8 with a negative out in front, the negative just stays there and continues with the problem. As you continue with simplifying these problems, the bigger the number is underneath the radical, the more factors, or the bigger the factor is going to end up being. Skip down to number 13. When we look at 13, we're looking at adding, subtracting. And then we have multiplying and dividing on the back part of this worksheet. So number 13, this is an addition problem, but I cannot add things that are not like terms. So I've got a square root of 2 plus, I can only add it to a square root of 2. And so I need to break down this square root of 50 if I can. If I can't, then I'm done. This is the end of the problem. But luckily for us, we can. So I've got a square root of 2 plus, I can break down the square root of 50. This is the work that we just did above. I know that 50 is 25 times 2. So I can continue this. The square root of 2 plus the square root of 25 is 5 square roots of 2. There's a lazy 1 in front of that square root of 2, so I've got 1 square root of 2 plus 5 square roots of 2 gives me 6 square roots of 2. It continues to be the way that you do these problems when you have 2 or 3 when you're adding or subtracting together. So we'll break down the 98. 98, if you don't know what goes into 98, you can see hopefully that it's an even number, so you know for sure that 2 can go into 98. And when you divide 98 by 2, you get 49, and 49 is a perfect square. I have a 4 here. I'm going to break down the square root of 8 into 2 different numbers. The square root of 8 is 4 times 2. And then I've got plus 3, and I'm going to break down the square root of 128 into 2 different numbers. 1 hopefully being a perfect square. And again, you can do a combination of both of these. If you don't know what the factors of 128 are, then you can definitely go back and do the breakdown of 128. But if you recognize that 128 again can be divided by 2, you see that 2 times 64 is equal to 128, and 64 is a perfect square. But you could use the breakdown method in order to do that as well. So the square root of 2, that's not a nice number. The square root of 49, though, sure, that's a 7. Then I've got 4 times the square root of 4 is 2, and the square root of 2 we just talked about. I've got 3, the square root of 2, and I've got the square root of 64 is 8. Well, one more simplifying step, 7 square root of 2 minus 4 times 2 is 8 square root of 2, plus 3 times 8 is 24 square root of 2, gives me my final answer of 23 square roots of 2. 7 minus 8 is negative 1. Negative 1 plus 24 is 23. When we jump down to number 17, this problem is multiplying, so I need to multiply. The rules with multiplying are if the number is on the outside of the radical, then you multiply it with other numbers on the outside. If it's inside, go ahead and multiply it with the inside. Once you're done with the multiplying, then you need to simplify. So in this case, I've got 3 is the only number on the outside. On the inside, I've got 5 times 2 is 10. 10 times 3 is 30. Then when I look at breaking down 30, 30 is 6 times 5. 6 is 2 times 3. Nothing breaks down with the square root of 30, so that's my final answer. When we go to the back of this sheet, I've got, again, some adding and subtracting, multiplying and dividing, where the work is the same, or multiplying when the work is the same. When I look at number 19, though, I've got some dividing, so I've got that square root of 3 in the denominator. Again, there's 2 ways to do these. I can see that I've got a 48 on top underneath the radical and a 3 on the bottom underneath the radical. So if they're both underneath the radical and I'm multiplying or dividing, I can look to actually just do that division problem. In the same way that I have on the outside, I've got a 4 and an 8. So 4 goes into 4 once and into 8 twice. I can do 48 divided by 3. 3 goes into 3 once and into 48 16 times. So on top, I've got 1 on the outside, a square root of 16 on the inside, a 2 on the outside on the bottom, and a 1 on the inside. Well, the square root of 1 is just 1, okay, so I don't really need to do that. On top, that means I have the square root of 16, which is 4. On the bottom, I still have 2, and then that reduces to give me a 2. Let's take a look at that again for number 20. Number 20, on the outside, I've got 14 can be divided by 7 2 times and 7 divided by 7 once. Let's put an extra step in here. So I've got 2 square root of 150 divided by 1 square root of 2. The 150 and the 2 are both underneath the radical. So I can do the 150 divided by 2. 150 divided by 2, 2 goes into 2 once and 2 goes into 150 75 times. So underneath this radical, I have a 75. On the bottom, I have 1, and then the square root of 1, so I only have 1 on the bottom. If you want to put that there, then fine, you can do that, and that would be perfectly okay. Then I need to look to see if I can reduce this, or simplify it. So I've got 2, and then the square root of 75 is 25 times the square root of 3. And the square root of 25 is 5, so I've got 2 times 5 times the square root of 3, which is actually 10 times the square root of 3. It becomes a longer process when you choose to do it that way, but it can be done with dividing underneath the radical as well. Which then takes us to the bottom part, which is the other option for doing the division problems. If you have dividing, you can look at rationalizing the denominator. So I could have on number 19 and 20, I could have multiplied by the square root of 3 in 19 and the square root of 2 in 20 on both top and bottom, and it would have been okay too. So I could have followed the same process. So number 28, let's take a look at that one. Square root of 3 over the square root of 3. Multiply on top, I get 1 times the square root of 3, which is just the square root of 3. On the bottom, the square root of 3 times the square root of 3 is the square root of 9. So on top, I get the square root of 3. The square root of 9 is 3. And that's my final answer. The 3's do not reduce. The top one is under the square root. The bottom one is not. Do not reduce them. On number 29, I want to multiply by the square root of 29, square root of 2 over the square root of 2. Get rid of the radical in the bottom. So I've got 2 square roots of 2 on top over 2 times the square root of 2 times the square root of 2 is the square root of 4. The 2 times the square root of 2, the square root of 4 is 2. Now these 2's can reduce because they're both on the outside. And so that leaves me with just a square root of 2 on top. If you wanted to put all the ones around, you could do that. Here's a 1 there, there's a 1 there. So you could do 1 times the square root of 2 divided by 1 if you wanted to. That'd be okay. Let's jump down to, let's say 35. So I want to get rid of the root, so I'm going to multiply by the square root of 6. 48 times the square root of 6 is 48 times the square root of 6. I cannot multiply those two numbers together. One's on the outside of the root and one's on the inside. On the bottom, though, I've got 6 times 6, and those are both underneath the radical. So I can do the square root of 36. So I get 48 square root of 6 over the square root of 36 is 6. Again, you can skip this middle step here because if you know that when you multiply two things underneath the radical, they come out exactly the same as the number underneath that radical. And so square root of 6 times the square root of 6 gives you a 6. The square root of 12 times the square root of 12 gives you a 12, and so on. I can finish this problem off by reducing 6 goes into 6 once, and 6 times 8 gives me 48. So 6 goes into 48 8 times. So I get 8 times the square root of 6 as my final answer. So when we look at simplifying radicals, adding and subtracting radicals, multiplying and dividing radicals, rationalizing the denominator, that brings us to the end of the work that we're going to be doing with the radicals at this time. It will come back, so if you do not understand how to do this radical stuff, you have to figure it out. Come in before school, after school, it has to be done.